All right, so now that we have gotten into precipitation and all that other fun stuff, we're going to now talk about severe weather. And if you're following along on in your review book, we're on pages 147 to 151. Okay? Now, severe weather is death, destruction, and despair. Okay? Now, what are they? It's going to be mid-latitude cyclones. All right, which means that they're associated with low-pressure systems. All right? And they typically form between 23.5 and 66.5 degrees latitude. Okay? Now, mid-latitude cyclones are also going to form from those occluded fronts. And you have to remember that occluded fronts are when you have a cold front catching up or moving faster than a warm front, right? So you have the cold air from the cold front moving into the warm air from the warm front, which is also got cold air all the way to the other side as well. So the faster moving cold front hits into the warm front, forcing the warm air up, and you get both the precipitation, the nice precipitation from a warm front, and the violent precipitation from the cold front at the same time, which then leads to these severe weather issues. Now, when it comes to severe weather, you need to know the types of severe weather, okay, how they are formed, what kind of damage do they do, and also what to do in case of that severe weather. So survival skills. Okay? So the first one we're going to talk about, which is like the baby one compared to the rest of them, are thunderstorms. Okay? Those are associated with those cumulonimbus clouds, those higher up clouds, the one that looks like an anvil. Okay? Because you have to remember, inside of those cumulonimbus clouds, there are updrafts and downdrafts at the same time. Okay? You get that uplift of warm air inside the cloud. Okay? Just something to point out, guys, the uplift and the downdraft that I'm talking about never really touch. So you have this uplift of warm air at the same time that there's a downdraft. They don't really touch. That's why they don't really interfere with each other and they don't really counteract with each other. Okay? So let's see how thunderstorms are going to form. Remember, guys, any videos that I give you, you're responsible for knowing and taking notes. If the internet wants to work. So just letting you guys know, you don't need to know the individual ones. If you want to write it down, that's fine. But you're not required to know the difference between a single cell and, you know, a squall line kind of a thing. But they do matter in the difference of the damage that they can do. Okay, so you don't not necessarily need it for the regions, like I said, but if you watch the weather at all, they might talk about it a little bit, so you'll know about it. Nimbus cloud, right? So, like it says, it's going to pull the moisture in, which you can see by the fact that it's a darker color, right? That updraft pulls the moisture in, the downdraft pushes the moisture out, and depending on how fast it's going to move, you end up with a storm that looks like this. Now, storms like this, you can see that this is a field. Right? If it's an open field like this, what you should do if you're running or trying to get home, okay, is you should make yourself as flat as possible. Okay? And they actually say if you're going to get struck by lightning, the best place to get struck by lightning is your butt. And the reason is because it's the fattiest part of you. Okay? I know it's very weird to think about, but it is. All right? So you're going to make yourself as flat as possible. Something you don't want to do in the case of a thunderstorm is go run underneath a tree. And the reason for it is, yes, even though it's going to stop the rain from hitting you, you saw there's a buildup that happens inside of a cloud, and that's where lightning is actually created. You guys, if you have any younger siblings, you can actually create lightning. You take a black garbage bag and you tape it to your floor. Make sure it's on a piece of rug, okay? And it's not going to move. You don't want to like rip up your rug either. You can take a metal top to one of your pots. If you rub it really fast, and then you pick it up slowly, you can create little bits of lightning. In other words, all it is a static charge, right? You've probably done it before where you're like, and then you go and touch something metal, and if you go slow enough, you can actually see lightning jumping from your fingers. It's kind of cool. Okay, so let's talk about tornadoes. All right, so we're building up. Tornadoes are going to be the fastest and most dangerous storms. They are the fastest and most dangerous because they move in and out of areas quickly. Okay? There's very little warning system. Okay? Tornadoes are usually associated with thunderstorms. Right? At the end of that video clip, you saw how there was a tornado that took down all of those houses. Okay? So how are they formed? These are formed by having a warm front or a warm air mass come in contact with a cold air mass, but it has to be a very large temperature difference. Okay? You can always tell when a storm is about to happen in general, especially during the summer, because that's when it's the warmest here. If you are outside and all of a sudden it's nice and hot out and you're not standing by like the beach kind of a thing, you get hit by like a nice cool breeze, you know something's going to happen. All of a sudden, that's how you're going to see some sort of a storm come in. You okay with that? Mm-hmm. Okay. This is called the EF scale. All right, take a picture. All right, the EF scale is how we categorize tornadoes. The thing with the EF scale is it is based on the damage that has been caused by the tornado. Okay? It's not necessarily based on the wind speed. The wind speed is going to tell me how much damage should occur. But if you have a tornado in an open field and there's no damage, quote unquote, it doesn't run over houses, it doesn't go into buildings, then even if it has 200 plus miles per hour winds, if it doesn't create any damage, it's going to be categorized as an EF1. So tornadoes are categorized based on how much damage they do. Okay? These people here are known as storm chasers. And I just realized it the other day because he's got a little bumper sticker here and it says Chase Life and it's got a tornado in the middle. He is a storm chaser. Storm chasers are adrenaline junkies and scientists most of the time. Okay? Usually they're curious about how tornadoes work. You get enough into it, you get paid to do this. And the thing is with tornadoes is since they come on so fast, you want to know how to predict them. It's very hard right now to predict when a tornado is going to show up. You can say there's a possible tornado, or it is likely that a tornado is going to come through. But especially up in New York, I honestly had not heard of a tornado touching down until when I first started here 12 years ago. Okay? About 12 years ago, never forget, because I was going to take off on Friday anyway because I wasn't feeling well. I got a phone call that the school's closed. Okay? I turned on the news. They said it was because a tree went through, and I can't remember if it was east or west. I think it was east. East Bottom. And the reason the tree went through East Bottom was because we had a tornado touchdown right there. Okay? Not right here on Peck, but behind Peck. Okay? In the complex that is back there, a tornado touched down and ripped up all kinds of trees. There was another tornado that touched down on the Long Island Railroad, which knocked out parts of the Long Island branches. Okay? I have never heard of that before. My parents had never heard of a tornado touching down in New York. My grandparents had never heard of a tornado touching down in New York. Now, if you watch the weather, in the last 12 years, they have become more common. Why? Because of climate change. Throw it back at you a little bit. Okay? This one, I believe, was categorized as an EF5. Except, it looks like an EF5. Right? It looks big and nasty. But even the biggest and nastiest looking storms may not do as much damage as you would think. Okay? So let's look. Here's a picture of the damage that a tornado has caused. Right? You can see what buildings are actually left. You have the Napa Auto Parts down here. You have part of the church, which is right behind it. And if you look in the top left-hand corner, you see some school buses. Some of the school is still left. Those three buildings were made out of brick and metal. Pretty much everything else that if you look around that is still standing is made out of brick or metal or stucco, which means concrete, basically. Right? Everything else is made out of wood. Tornadoes will take down wood like you are snapping a toothpick. Okay? Tornado Alley. It's nicknamed Tornado Alley because it's the perfect storm location for tornadoes. Mostly, the tornadoes will happen in Texas, Oklahoma, Kansas, Nebraska, Iowa. Okay? Parts of Colorado get it, parts of South Dakota, and parts of Minnesota. And if you look, like I said, it's the perfect storm. You have cool, dry air coming down from Canada. You have warm, moist air coming up from the Gulf. And you have warm, dry air coming up from just Mexico in general. So when those three meet, those are extreme differences, you get tornadoes. So let's watch what happens.
After a destructive tornado occurs, the National Weather Service surveys the damage to estimate the tornado's wind speeds. The tornadoes are then rated by their intensity using the EF scale, from the weakest EF0s to the rare, incredibly powerful EF5s. In this video, we'll observe examples of each, as well as the damage each rated tornado can cause. Not all tornadoes have the strength to cause severe destruction. In fact, about 75% of tornadoes in the USA are relatively weak, falling in the EF0 to EF1 range. A tornado rated EF0 has wind speeds estimated between 65 to 85 miles per hour. They can cause light roof damage, including damage to gutters or siding, break branches off trees, push over shallow-rooted trees, and mess up hairdos.
Somebody's trampoline.
EF1 rated tornadoes are stronger, with estimated wind speeds from 86 to 110 miles per hour. They cause moderate damage, such as roofs severely stripped, exterior doors ripped off, and broken windows. Cars are moved and mobile homes are badly damaged or overturned. Just because a tornado gets a low rating doesn't mean that tornado is small. Have a look at this 1 kilometer wide EF1 near Denton, Texas. There is no signature appearance for any of the EF ratings. All categories manifest themselves in arrays of shapes and widths. EF2s cause considerable damage, with estimated wind speeds between 111 and 135 miles per hour. Roofs are torn off well-constructed houses. Mobile homes are completely destroyed. Large trees snapped, and cars are lifted off the ground.
Here's a lawnmower. I don't even know where it came from.
Tornadoes rated EF2 and above are labeled significant tornadoes. Day of severe weather forecasts by the Storm Prediction Center give probabilities for the chance of tornadoes. If conditions suggest a risk for EF2s or larger, the Storm Prediction Center gives that area a special heads up outlined in black. EF3s have estimated wind speeds from 136 to 165 miles per hour. They cause severe damage to well-constructed houses and large buildings. Trains are overturned, trees debarked, heavy cars are tossed, and structures with weak foundations are blown away some distance. This is the Sulphur, Oklahoma EF3 that occurred on May 9th, 2016. This monster grew to 1.4 miles wide, and mobile radar recorded wind speeds over 200 miles per hour. So why didn't this tornado get a higher rating? Remember, tornadoes are rated by the damage they create, and this tornado tracked over mostly open terrain with few structures to impact. Had its strongest winds hit a well-built house, this tornado would have likely earned an EF5. So basically, if the core of a tornado harboring winds over 200 miles per hour at the surface doesn't hit any structures, but its outer bands knocked over the lawn chair you left out at the fishing hole, that tornado gets an EF0. Tornadoes with wind speeds estimated from 166 to 200 miles per hour cause devastating damage and are rated EF4s. Well-constructed houses are completely leveled. Structures with weak foundations are blown away. Cars are thrown. This EF4 ripped an entire roof off its walls and tossed the obliterated bulk 100 meters into the air. Suspended roof trusses and 2x4s whirled around the tornado like feathers, eventually becoming missiles slamming back into the earth. After a tornado occurs, various locations of assessed damage are given EF ratings. The entire tornado earns its most severe rating, even if that intensity is only a tiny fraction of the damage swath. EF5s have estimated wind speeds over 200 miles per hour. The damage from these monsters is incredible. Often at an impact site, there's nothing to see because nothing is there. Strong framed houses are lifted off foundations and carried considerable distances to disintegrate.
There's nothing left.
Automobile-sized missiles fly through the air farther than 100 meters. Even steel-reinforced concrete structures are badly damaged. In southern Kansas, there's one town that's oddly new. That's because in 2007, it took a direct hit from an EF5 wider than the town itself. 95% of Greensburg was destroyed. Empty lots and debarked trees are the ghostly reminders as the town rebuilds.
All right. Kind of crazy, right? If we have time, I'll let you guys watch that, but cancel. All right. But right now, we do not. So, all right. Last thing about tornadoes, right? The last thing you need to know about tornadoes is what to do if you are in that situation, okay? Any movie you've ever watched that has a tornado happen, you hear that air raid sound, you hear the air horn, you might even hear this is not a test of the emergency broadcast system, get to shelter, okay? Since tornadoes move so quickly, you have a very short window of opportunity to basically get to shelter. You're not going to go run to the nearest building that you can. You're going to try and find a basement with no windows or a bunker underground. Again, every movie you've ever seen, you see people running out of their house to the middle of a field to go underground, okay? The thing with tornadoes is that they are so strong and so fast moving that they can actually make windows implode. Or basically, the pressure changes so much, it pushes inward. Okay? In those movies, a lot of times you'll see people open the windows real quick so that there's not a huge pressure change and they will be less likely to actually take the house with them. Okay? So you need to find a bunker or some underground shelter. Okay? Usually that underground shelter has a change of clothes for yourself in case you're there for, or in case your house gets knocked over. You'll have bottled water. You'll have flashlights with batteries. You'll have canned food, the normal bunker type thing. But again, you want to be underground, okay, with rations enough so that if the tornado does go over you, you guys aren't ripped up out of the ground. Okay, so bottled water. You want to have a safety kit or a first aid kit. You want to have a flashlight with batteries, and I don't know why you guys aren't writing these things down. It's kind of something you need to know. Okay? Tomorrow, we will start with hurricanes, because this ends in 2 minutes. Okay? So tomorrow, we will start with hurricanes.